Hi there, welcome to iTWire TV. Today we are delighted to announce that we're talking to Ami Badani, the VP of Networking for Nvidia, and John F. Kim, Director of Storage Marketing and Bluefield DPU. Today we're here to talk about the Bluefield DPU and the great work Nvidia is doing there. The Bluefield DPU has been described as the third major processing unit that will define the next decade of computing. So I'm really excited to speak with you, Ami and John, and yeah, really grateful for your time. Thank you so much.
So, great to be here,
David. Having us.
Thank you so much. I guess, can you start by sharing what a DPU is and why Nvidia has developed the Bluefield DPU?
Yeah, maybe I can kick it off and just kind of describe a little bit about the data processing unit. In short, we call it the Bluefield data processing unit. Now, if you look at like over time and you look at sort of what compute and accelerated compute has done over time, what you're seeing is that Moore's law is really slowing down. And in terms of, adding compute capacity, CPU capacity to your current workloads, that's sort of not going to be able to pay off in strides as it once was before. So what we've announced about 2 years ago was the introduction of the Bluefield data processing unit. And the way to think about Bluefield is essentially it's a processor that's highly specific and intended for large data-intensive packet processing type workloads. So think networking, security, storage, any of those types of workloads that require lots and lots of packets that are traversing the network. And so when you think about, all your different applications, what you really think about is you need today about 30% of your compute is being consumed by these infrastructure heavy workloads, networking, security, storage, all of that today is running on a CPU. And now you think about sort of over time, as a lot of these applications, like AI applications come to the forefront, you'll need very specific processors to do these very intended tasks. So for example, for us, a lot of what we think about is artificial intelligence. And artificial intelligence, the future will really be defined by artificial intelligence. The CPU wasn't really designed for parallel processing type applications. So we have the GPU, which is very well known, across the industry to really accelerate the performance of artificial intelligence type applications. The DPU is sort of a kind of the next leg of that stool, and it's really focused on these data-intensive workloads where instead of running that on a CPU, you can now run that on a data processing unit. So within a data center, we like to think about the new unit of compute as the data center itself. So you have the CPU that's great for single-threaded type applications, business-critical applications. You have the GPU that's great for parallel processing, and now you have the introduction of the DPU, the Bluefield DPU, that's great for data-intensive type processing of applications. So we really think about this trio of the CPU, the DPU, and the GPU together really forming that new unit of compute within the data center.
Right, tremendous. So if I would say then, in what ways the CPU is better for the data center compared to the CPU or GPU, it's what you've just described. It allows you to concentrate the data-intensive activities through that piece of silicon instead of having to consume CPU. Right, I understand. Okay, so how then does the DPU fit in with NVIDIA's overall offering for enterprise?
Yeah, so the way that the DPU fits in is it's actually a core and central part of our data center offering. So as I keep mentioning, as artificial intelligence applications, we're seeing that today, and it's still a small portion of the data center, but over time, the future of AI will really be accelerated. And so what we believe is that as AI comes to the forefront of the data center, you'll need networking, security, storage to really fuel and power these AI applications. And what we intend is for all these infrastructure workloads to really be invisible and just work. And all of that offloaded and accelerated onto the DPU. So one of the things I didn't mention was the capabilities of the DPU are really threefold. One is offload, so you can offload certain tasks onto the data processing unit. Accelerate, so you can actually run those same tasks on your DPU in a much faster way than you were on the CPU. in Isolate, which is really focused around isolating and creating a secure and isolated perimeter around your applications that run on your DPU. So you can offload, accelerate, and isolate. Those are the kind of the three value adds of the DPU. And so, as I mentioned, as the future of business becomes AI accelerated, we really believe that these central core functions, data intensive functions, will need to be offloaded, accelerated, and isolated onto the DPU, such that the AI applications become much more efficient. So it's really part and parcel of our data center strategy here at NVIDIA.
Yeah, I want to add.
Oh, sorry, John. Yeah.
Oh, David, I just wanted to add to that, as Ami said, these days, if you don't have something like the DPU, you're sacrificing as much as 30% of your CPU power to running all this infrastructure, all these functions, so the networking, the storage, the security, the management, and really customers can't afford to do that anymore. They've got these very valuable, expensive CPUs, and they want to use all that power to run the applications. And so if there's any task that can be done more efficiently by the DPU, it makes sense for the customers to offload it to the DPU. And likewise, if they're, especially in the world of AI, as Ami said, AI is coming to every business if it isn't there already, then it makes sense to offload the AI computation to a GPU and then the infrastructure tasks to a DPU. And then you get better efficiency, better performance, and quite likely better energy efficiency as well.
Right. Actually, John, that leads into my next question, because I was going to ask, one of the major challenges in data center is power consumption. So, if we're talking about adding a third processor, is there a concern there? I guess, but what is the power efficiency of the DPU and how are you achieving that?
Sure. Yeah. So, Ami, well, let me go ahead and start with that. Yeah. So we've done testing and we found that because the DPU is so much better at doing the networking or the encryption, doing the storage virtualization, when you run these types of tasks on the DPU instead of on the CPU, you typically get better performance and you use less power. So we recently published a white paper and a blog about that, and we have more testing going on both within our own labs and with some of our key partners, where we're measuring the power savings. And we actually see that in many cases, the server uses less power when you transfer these tasks to the DPU. And in the bigger story, actually on the GPU side as well, we also see that for, again, parallel tasks that can be very parallelized, or which are very math intensive or visualization intensive, graphics intensive, often you get a lot better power efficiency by moving those to a GPU, in addition to moving the the networking and the storage and the security to a DPU.
Yeah, I think to add to that, if you look at kind of the ways to reduce power, there are really 5 ways to reduce power. One is reallocate workloads to areas with cheaper electricity. So we're seeing different companies do that. Second is improving the power usage effectiveness, like improving cooling efficiency or more efficient lighting or one of those aspects. And I think more or less people have maximized their PUE. The other way is outsourcing to a large cloud provider, which many companies are doing. But the two that I think are often overlooked, and this is where I think the DPU really plays in, is maximizing server utilization. So having fewer servers do the same amount of work. And that's where, when you add the DPU, now you can offload and accelerate those data intensive tasks to the DPU. And then ultimately you need less servers to do the same amount of work, or actually less servers that do the work more efficiently is sort of the better way to put it. So fewer servers lead to better power effectiveness, because ultimately you're consuming less power. And then also improving the power efficiency of servers in general. So now when you're offloading and accelerating certain data intensive tasks, because the CPU was never designed to run those specific workloads, as John mentioned, you're offloading and accelerating that on the DPU. And so that server, in essence, becomes more power efficient, even though you're adding this additional processor, which requires more power. In essence, you're actually consuming less power. We'll kind of walk through some of those studies so you understand, how this translates into a direct dollar benefit.
Yeah, wonderful. No, thank you both. So I guess, I'm sold on power, but what about security and storage? How does the DPU stack up in those areas?
Yeah, so one of the big areas
of...
Oh yeah,
go
ahead, Ami.
Go ahead, John. Why don't you cover security and storage?
All right. So security has a couple of aspects, and so a common one that people really, or it's really easy to understand, is the ability to do encryption. If you believe in a zero trust security stance, that means several things. It means that you cannot trust other servers in the data center. You have to operate as if someone might have already broken in through your firewall or be in your data center. So one of the things people do to prepare for that is they encrypt all the traffic between the servers. But this encryption and decryption takes, if you do it in the CPU, which is the way people originally were doing that, it takes a lot of the CPU cores to do that. The DPU, in the case of Nvidia's Bluefield, has special silicon that's really efficient at doing encryption and decryption, and it can do it at a couple different levels. So that's one area of security that's very easy to offload to the DPU, and that's in the white paper where we talk about how that you can reduce the power usage per server by offloading the encryption to the DPU. In addition, the DPU is also really good at, for example, running a distributed firewall. So that's something where previously instead of saying I'll have a firewall just at the perimeter of the network, you can now say I'll have a firewall agent running on every server, but it's not going to impose an extra burden on the CPU because the DPU is taking care of that and running it. And then third, there is a security isolation capability. So, actually, third and fourth. So, third, there's a network security capability, and then fourth, you have security isolation. So, network security is, for example, the ability to do access control lists, or to detect suspicious traffic, or to block unauthorized users from accessing a server. So that can all be put into the networking rules that are offloaded onto the DPU. And then the isolation is the ability for the DPU to run security software or the networking or the firewall separately in a separate domain from the regular CPU. So if the CPU or the hypervisor or the operating system is compromised, you still have that protection in that the DPU is running the security separately and is not compromised and is still able to detect and isolate that security threat on the server.
Okay. That's fantastic. And, I understand that NVIDIA has a partnership with VMware and on VMware vSphere 8 running on the Bluefield DPU. In fact, that quote I mentioned at the beginning about, DPU being described as a third major, processing force for the next decade, that came from VMware, and they're certainly speaking up what they want to do in partnership with NVIDIA on the DPU. So I guess, what value does this bring to the market, the partnership with NVIDIA and VMware, VMware vSphere 8 running on the Bluefield DPU? What value does that bring?
Yeah, we've been working with VMware for quite some time with the Bluefield DPU. In fact, about 2 years ago, we announced a joint project together called Project Monterey. And essentially, we're realizing the first phase of that vision. But it's essentially taking the vSphere operating system and running that on, offloading and accelerating that on Bluefield, and eventually providing security isolation. And we'll be able to offload networking and security and storage and some of those key components of vSphere workload. So we actually introduced the first phase of that vision earlier last year. That was in August. We just started shipping systems with Dell, where we can actually there's Dell systems with a Bluefield DPU that you can get right off the bat, and then you can run the vSphere operating system on Bluefield. And so what this entails is obviously less cores consumed, so you're not actually running that on the CPU, and vSphere becomes more efficient by running that and a lot of the other respective application workloads on the Bluefield. So we actually did this study where we took the Redis key value store. It's a popular key value store used in a lot of gaming applications and other applications that require low latency and fast transactions. And we took this Redis key value store, offloaded and accelerated that on vSphere running on Bluefield. And what we were able to see is specifically on the core savings, not only were we able to run this at better performance than you were on the CPU, but you were able to also save cores. So in the absence of a Bluefield DPU, you would essentially consume 12 cores by running that operating system. Now completely offloading and accelerating and offloading that on the Bluefield with the Redis key value store, you're now able to virtually consume 0 cores. Right. So what this translates to is now you can save servers, right? You don't need 12, you don't have to reserve 12 cores to run this application. So now you need fewer servers to do the same amount of work. So then when you kind of translate that and you look at the dollar per kilowatt hour, and you translate that to how many servers you save, and you look at a mid-sized data center of 10,000 servers, I think we were projecting somewhere in the magnitude of around $60 million over a 3-year time horizon. So huge power savings just by reducing the server footprint in a mid-sized data center.
Yeah, that's fantastic. That's brilliant value. And just moving sideways slightly, so Nvidia is also a co-founder of the Linux Foundation. So I guess in what ways is Nvidia involved there, and how does that relationship benefit the industry as well?
Yeah, one of our core tenets is really making sure there's proliferation across the ecosystem. I mean, we really believe and pride ourselves on open source and embracing open source and making sure that there's a pathway for everyone who wants to adopt our accelerated computing platform, all the way down to the hardware and all the way up to the software, has the ability to do that. So Linux Foundation has really been instrumental in helping us achieve that. And so, as and when we can drive towards open standards, we really try to drive towards that and embrace open standards. So with Linux Foundation in particular, one of the projects that we recently became a co-founding member of is the OPI project, which stands for, I think it's Open Project Infrastructure, though I'm not sure if that's exactly
Open Programmable Infrastructure.
Open Programmable Infrastructure. Sorry, thanks for correcting me, John. And one of the things that that was sort of one of the main projects that has been really formed around the DPU, and really making sure we can get open standards driven into the industry. And so we've been a co-founder of that project for a little less than a year now, and we've done things like design requirements of how server systems should be designed with the Bluefield, and what are those specific requirements, and working closely with all the OEM vendors to make sure that they understand how Bluefield and other DPUs can be designed into servers now and in the future. There are specific use cases that we're exploring with that foundation to figure out how we can really drive those use cases into the industry, so people have an understanding of how they can use the Bluefield in real-world applications. We've also contributed, open standards, whether it's on networking or security or storage. There are a bunch of open standards that we're contributing to that to the OPI Foundation, such that others can really embrace it and leverage building applications on top.
Okay, fantastic. This is awesome things that you're saying. So earlier you talked about the great value for enterprise. You talked about the enhanced security and storage, and the fact that you can maximize your CPU utilization by offloading work to the CPU, and how you can save energy. So I guess I'm interested to know this seems very transformative. So what is NVIDIA's vision then? What of the data center of the future? What does the data center of the future look like with the great revolution that the Bluefield DPU can bring?
Yeah, as I mentioned earlier, for us, one of the big parts of the data center of the future is really reinventing the data center. So, as I mentioned, the data center is the new unit of compute. You'll have the CPU, the GPU, the DPU, all of these playing nicely together in this trio as the data center of the future. But, also what's important here is, as I mentioned, as artificial intelligence will become the most powerful force of our time, we'll really see the future of business AI accelerated. And so that's why all of these networking, security, storage being super important to the accelerated compute platform, and all of that being the way that the data center is being reinvented in the future, with Nvidia as a sort of a core part of that, from all the way down from the hardware to the full stack accelerated compute platform, not only at the chip level, but the hardware platforms, the software frameworks, the accelerated AI application platforms. All of that will kind of come together and become this sort of the reinvention of the new data center, the new unit of compute.
Yeah. Awesome.
Yeah, I definitely see pretty much every data center going to be becoming an accelerated data center, where an increasing percentage, more and more of those servers are going to have accelerators whether that's acceleration for AI or acceleration for the infrastructure or both. And so that's why Ami was saying that, it's the GPU, the CPU, the GPU, and the DPU are forming the foundation of the new data center.
Wonderful. Well, I'm certainly sold on the DPU, but I suppose, is it for everyone? Are there target customers who may be more suitable than others for the DPU, and what's their typical profile? Or is it for everyone, or is it, better for a specific set? I guess what's the profile of the typical DPU customer?
Yeah, I think there's sort of broad applicability because everyone sort of uses these data intensive type, applications, right? But there's definitely early adopters and sort of laggards, right? I think on the early adopter side, what you're really seeing is the cloud service providers. The cloud service providers, the tier 1, tier 2 regional CSPs, they're really the ones that are consuming this. And you kind of already seeing, if you're familiar with AWS Nitro and what they've done to design in their own data processing unit, or I'm not exactly sure what they call it, but AWS Nitro is a good sort of gold standard for what a lot of CSPs want in their own data center. And then, from there, there's enterprises that really want to consume, these types of DPUs because they want to offload and accelerate and isolate a lot of their applications, their data intensive applications. And so we'll see enterprises, start to consume. Telecom providers are really early validation of what we'll start to see of DPUs come to the forefront. So a lot of telcos adopting Bluefield. And I think there's, if you sort of think about it, there's really broad applicability across all of these industries. As we think about the ecosystem, what we'll see over time is like next generation firewalls. Instead of those running on CPU as they do today, we'll see next generation firewalls running on a DPU, a DPU accelerated next generation firewall. We'll see a lot of our storage appliances, instead of running storage appliances with the CPU, you'll see a lot of that running with the Bluefield. So there are sort of, we talked about vSphere, which is the operating system of the enterprise that's already, running on Bluefield. So you'll kind of see more and more of these applications that will be Bluefield DPU accelerated. And as a result, that will really drive a lot of the business for Bluefield and a lot of the interest for Bluefield.
Excellent. No, that's wonderful. So, you've said many great reasons, but I guess in a nutshell then, if you were talking to those enterprise customers or telcos or cloud providers, I guess what would be your, statement to them of why they should consider the DPU and now?
Yeah, I think for me, and maybe John can chime in, but it's not a matter of if, it's a matter of when, in terms of when DPUs will start to be consumed and designed in. We're working with every single OEM provider, and they're designing systems with Bluefield. So every single server out there in the future will have a Bluefield data processing unit, over the next year or two. So that will sort of be the tip of the spear. And then, if you sort of think about the core functionality of the DPU, offload, accelerate, isolate, you can kind of imagine the world of possibilities in terms of applications, infrastructure heavy applications that will need to run on a Bluefield, and then how customers can start to consume that. So as I mentioned, it's not a matter of if, it's a matter of when. And I really believe that all these forces will kind of combine, and we'll see a lot of good customer traction over the next year or two as Bluefields really become the new unit of compute, or really the next generation of infrastructure compute.
Fantastic. That's been so educational. I appreciate your time so much. So that's been Ami Badani, VP of Networking for Nvidia, and John F. Kim, Director of Storage Marketing and Bluefield DPU for Nvidia. So Ami and John, I've learned so much, and I really appreciate your time. That's been wonderful. Thank you.
Thank you. Thanks for having us.
Yeah, David, thanks for having us.
No, thank you. Thank you.